In this video, I am going to create Maclaurin series for a couple of different functions. Okay, the first function is f of x equals 5x times the cosine of 1/8 to the x squared. And so this looks similar to the cosine of x function. And so we are going to build on the Maclaurin series representation for cosine of x. So in a previous video, what we learned how to do was for the cosine of 1/8 to the x squared, we simply take out the x and we put in the 1/8 x squared in its place. And so we simplify that, and I did the simplifying up here to keep it kind of out of the way. 1/8 squared, x to the 2n becomes x to the 4n over 8 to the 2n. And so I wrote that down here. Now, what about the 5x? 5x is being multiplied to this function, so I am multiplying it to the function, or to the power series, to the Maclaurin series. So if you can imagine, this is the power series representation right here. And if we were to go and find the Maclaurin polynomial and find every single term of the Maclaurin polynomial out to infinity and multiply every single one of those terms by 5x, that's essentially what we would have to do. But there's an easier way. And so as it turns out, again, using the properties of power series that we learned, what we can do is we can bring the 5x into the power series here and multiply it right in there, because it's essentially the same thing. Okay? Instead of writing it out here, we're just writing it here. So it's like the summation of the power series times 5x. Well, now it's easier to see that we can combine these terms. The 5 just comes out in front, and so then we have x to the first power. Getting a little messy here. So we have, let's go to green. So once we remove the 5 and put that out front, we have x to the 4n times x to the 1, which becomes x to the 4n plus 1. And of course, this 8 to the 2n is down here, and everything else is pretty much the same. So here is our Maclaurin series representation for 5x times the cosine of 1/8 x squared. So you could show that this Maclaurin series represents this function over a given interval by graphing it. You could graph the function, and then you could graph different partial sums of the Maclaurin polynomial, the first term, the first two terms, the first three terms, on, and see how we get a greater and greater approximation. And if you wanted to determine the interval of convergence, which we'll do in another video, is you could use the ratio test to determine what exactly is the interval of convergence. All right, let's do one more. The sine, 7 times the sine squared of x. So at first it looks like, well, perhaps what we could do is just use the sine Maclaurin series. But because it's sine squared, there's a better way of doing this. We go back to our trig identities. We haven't used this in a while, but we used this back a lot when we were doing techniques of integration or applications of integration, that the sine squared of x is equal to 1/2 times 1/2 cosine of 2x. All right, then we're multiplying that by 7. So multiplying through both terms by the 7. And now let's look for a power series representation of the cosine of 2x. And so what we're going to do is we're going to replace in the cosine Maclaurin series, we're going to replace x with 2x, just like we've done before. And so that's going to become 2 to the 2n times x to the 2n. To kind of break it apart a little bit, that becomes this. And then we want to multiply it by 7/2. So multiplying the 7/2 through here and just bringing the 7/2 into the power series, because again, you can imagine we're going to have a Maclaurin polynomial, and we're going to multiply every term of that polynomial by 7/2. Right, now that then gives us our Maclaurin series representation of 7/2 times the cosine of 2x. And so the tricky part is, what about the 7/2 that's sticking out front here? Well, you're going to notice that the index starts at 1 down here, but it starts at 0 originally. And so if you change the index to 1, then the first term in this Maclaurin polynomial, the first term is going to be 7/2. And so what happens is this 7/2 minus this will cancel out. And so what we end up with is basically this power series representation starting at n equals 1. And again, the reason it's starting at n equals 1 is because the first term cancels out and becomes 0. And so we have our final power series representation for the sine, 7 times the sine squared of x being this. And so play with it a little bit. Find the first few terms of this Taylor polynomial right here. And then see that the 7/2 will end up canceling out. All right, that is going to be it for this video. I'm making shorter videos because my video recording device sometimes doesn't work and I have to repeat these all over again. So I'm doing them in smaller bites.